Hello, my dear children of Class 12 Science. Today, again, I welcome all of you through this mode of teaching that we are following. And we are following what mode? A YouTube mode. And in today's class, we start a new unit. Okay, in Class 11, Class 12 syllabus, that is unit number 8. So, this is important unit for semester 2 examination. And the unit name is Atoms and Nuclei. Okay, under this unit, we have a number of chapters, but we start with the first chapter of this unit, that is atom, origin of spectra, Bohr's theory of hydrogen atom. This is the chapter that we learn in details. Okay, now to start this class, this particular chapter, okay, so we try to understand the experiment. We try to understand the experiment which was performed by two scientists, Geiger and Marsden, followed by the Rutherford, the Ernest Rutherford. Okay, and the name of the experiment is alpha particle scattering experiment. Okay, what experiment? Alpha particle scattering experiment. Actually, this experiment leads to the discovery of nucleus, one of the what central part of the what atom. Okay, now for this experiment, okay, two scientists. Okay, the name of the scientists are Geiger and Marsden. They were actually the student of Rutherford, who performed an experiment. But after certain years, okay, Rutherford make the verification of this experiment, saying that atom has the central part, okay, and that central part of the atom is called nucleus. But we can make number of conclusions from this experiment. So in the year 1909, the two scientists, Geiger and Marsden, they were actually the what? Students. They were actually the what? Students of Ernest Rutherford. Ernest Rutherford, one of the great scientists who actually made the discovery of what? The nucleus, one of the central part of the what? Atom. Okay, that means this chapter is full of what? This atom and the origin of what? Spectra. Okay, origin of what? Spectra. Now, students of Ernest Rutherford, okay, perform an experiment. Perform a number of experiments, usually a number of experiments, to observe the scattering of alpha particle. Scattering of what particle? Alpha particle. Now, to understand the scattering of a particle, the question arises out there is, what is alpha particle? Now, you know, alpha particle is one of the particle consists in the ray known as alpha ray, which emit from the radioactive elements. So, alpha particle is the what? Particle. Okay. Particle, and what type of particle? A positive charge particle. A positive charge particle. And basically this particle is also called helium nucleus. The alpha particle is the positive charge particle called helium nucleus. The children, one of the chapter nucleus. One of the chapter you learned in class 10, and it was there in class 12 syllabus, but as per reduced syllabus we didn't do. Okay, and the chapter name is radioactivity. So you have learned in class 10 also radioactivity. Radioactivity is a phenomenon where there is an emission of alpha ray, beta ray and gamma ray. And alpha ray emit from the element, like radioactive elements emit a particle called alpha particles. And alpha particles are always a positive charge particles. Okay, positive charge particle. And this is basically a what nucleus? Helium nucleus. Okay. Now, at that time, the discovery of alpha ray from the radioactive element was already made. So they took this alpha particle. Okay, they took what? Alpha particle. Okay, and this alpha particle made to emit from one of the radioactive elements like polonium. Okay, so polonium is one of the radioactive element which emit what? Alpha ray, consist of alpha particle. Now this alpha particle was made to incident or fall on one of the very thin foil, and this foil is called gold foil. I'll tell you why the gold foil is taken. Okay, but the main objective of this alpha particle scattering experiment is to do the discovery of what? Atomic nucleus. Because that means the Geiger and Marsden experiment on scattering alpha particle actually leads to the discovery of what? Atomic nucleus. The main objective. So let me write down the main what? Objective. The main objective of the experiment. Okay, which experiment? Alpha particle scattering experiment. Okay, main objective of alpha particle experiment is to what? The atomic nucleus. Okay, so children, keep in mind that what is the main objective of alpha particle scattering experiment is to do the discovery of what? Atomic nucleus. So for that, as I said already, they took one of the radioactive source, like the element that is called the polonium. Okay, from there the alpha particle was made to fall on what? A very thin foil, and this foil is called gold metal foil. Gold metal what? Foil. Because gold is such a metal, okay, which can be drawn into a sheet, a very thin sheet. Because metal has a number of properties, and one of the property is called malleability. Okay, malleable. That means metal can be drawn into sheet, a thin sheet. So as for the experiment observation and the arrangement which was done by these two scientists called Geiger and Marsden, okay, as I said, they took a metal foil that is called gold foil, a very thin sheet of gold foil, okay, and they made the what? Beam of alpha particle from the radioactive elements to incident on the gold foil. So if you look at the diagram, children, these are the incident rays, these are the beam of what? Alpha particle which are coming out from the radioactive elements, and this beam of alpha particle was made to incident or made to fall on the gold foil. Okay, now once they made to incident on the gold foil, they observed that this alpha particle was found to be scattered, okay, which was found to be scattered in different direction and at different angles. Okay, so with this observation, okay, they counted how many alpha particles were scattered by what angle. So in order to count, they use one of the detector, and this detector is called scintillation counter. So this is just like a microscopic device. It's just like a microscopic device, or we also call detector, which can detect how many what alpha particle were scattered. Okay, scattered by certain angle. Okay, so with this experimental observation, it was found that the particles, like alpha particles, while passing through this gold foil, okay, passing through this gold foil, were deflected. Deflected outer means scattered, okay, through a wide range of angles. Not only with a certain angle only, with a wide range of angle, from 0 degree to say 180 degree or 360 degree. Okay, so under this case, the particles scattered in different various directions were actually counted by the counter, as I said, that is called scintillation counter. So it was found that almost most of the alpha particles, when they counted the number of scattering of alpha particle with the help of scintillation counter, it was found that almost most of the particles, most of the alpha particles, okay, scattered, okay, most of the alpha particles scattered through an angle of the order of say 1 degree, at an angle of how much? 1 degree, or less than 1 degree. That means most of the alpha particle was passed straight without much deflection. But a very small number, very small number of alpha particle scattered through how much degree? 90 degree, or even say 180 degree. So what happened under this case? This large angle scattering of alpha particle, okay, could not explain at all by these two scientists. That means these two scientists could not make any conclusion that why the particle are scattering mostly, why the particle are scattering very less with large angle, okay, where the particle are, most of the particle are passing straight, okay, with less angle of scattering. So they could not make any conclusion. So under this case, the observation made by these two scientists for the scattering of a particle was remain unexplained. So what happened after 2 years, that means in the year 1911, Rutherford explained the large angle scattering of alpha particle. Okay, large angle scattering of what? Alpha particle, by doing the same experiment again. Okay, what the experiment was performed by these two scientists, and with that observation made by the Rutherford, number of conclusion was made. But one of the most important conclusion that was made by Rutherford is the discovery of nucleus, and this nucleus is called atomic nucleus. So in the year 1911, as I said, after 2 years, where two scientists performed this experiment called alpha particle scattering experiment. Okay, Rutherford, the Ernest Rutherford, made an explanation, the clear explanation on the scattering of alpha particle. Means why large range of scattering of a particle takes place when that alpha particle were made to incident on the what? Gold foil. Okay. Now, as I said, this experiment the main objective of this experiment is to do the discovery of what? Atomic nucleus. Okay. That's why when Rutherford observed the same experiment in the 1911, he even found that most of the alpha particles pass straightway through the gold foil. Now, why passing straightway through the gold foil? Because when alpha particle are made to incident on the gold foil, it will incident on the what? Atoms of the gold foil. Atoms of the what? Gold foil. But let me just tell you, this foil was taken very thin so that there is only a single atom present in the layer of the gold foil. Okay, so that when alpha particle goes and strike on the atom, it will strike on each atom of the gold foil. So that after striking to the gold foil, that alpha particle will get to be scattered, will get to be deflected. But one of the first observations which was made by Rutherford was most of the alpha particles pass straightway through the gold foil without much deflection. Okay, so from here Rutherford made a conclusion that the atom is mostly hollow inside. The atom is mostly what? Hollow inside. Due to that, most of the alpha particle pass straightway. So one of the first conclusion which was drawn by Rutherford is most of the atom is mostly hollow inside. That's why whenever alpha particle pass through the atom of the gold foil, that alpha particle pass straightway without much deflection. So this is one of the first observations. Now the second observation explanation which was made by Rutherford is some of the alpha particles were deflected at a small angle. So what is the second explanation which was made by the Ernest Rutherford? As I said, some alpha particles were deflected at small angle. Okay, small what? Angle. And it was already made a discovery that alpha particle is a positive charge particle. So as I said, since alpha particle are positive charge particle, so that's why as for his observation, he said that the part of the atom deflecting them must also be what? Positive. That means there must be a positive charge particle of an atom, okay, which must deflect these alpha particles. Because between positive and positive, what happened? Repulsion takes place. Always repulsion takes place, and repulsion is also one of the force. Okay. So as for his conclusion, he made that the whole of the positive charge of an atom must be concentrated in a very small space. Must be concentrated in a what? Very small space. So the second observation or explanation is actually made by the Rutherford is that the whole of the positive charge of an atom must be concentrated in a very small space. Very small space. And due to that, very few or some of the alpha particles were deflected by very small angles. So a small deflection of a particle is due to this second reason. Now the third and the most important observation and the explanation which was made by Ernest Rutherford is that he found that very few of the alpha particles were scattered at angles greater than how much degree? 90 degree from their initial path. Means when the alpha particle was made to incident on this atom of gold foil, okay, with their initial path, very few of the alpha particle was found to be deflected with an angle greater than how much degree? 90 degree. So from this, it is evident that when high speed alpha particle, which are the positive charge particle, pass through the atom of gold foil, then very few of the alpha particle experience a strong repulsive force. See, a very strong repulsive force, so that they will return back, okay, at an angle more than how much degree? 90 degree. So children, in order to understand this particular observation which was made by Ernest Rutherford, as I said, in this experiment, he was observed that out of many alpha particle which was made to incident on the gold foil, very few alpha particles may consider, let me just consider, say, 1 in every 10,000 alpha particles were found to be scattered through how much degree? 90 degree or greater than 90 degree. Okay, so why it is happening? Why it happens? Because when alpha particle return or reflect back with an angle greater than 90 degree, means that alpha particle almost reach to what? The atom of gold foil, the central part of the atom of gold foil, and exert a very strong repulsive force. Because alpha particle are the positive charge particle, they move with a very high speed, and his observation said that there is a positive charge of the particle which are concentrated in a very small space, where this particle, positive charge particle, okay, can also exert a repulsive force. But what type of repulsive force? A strong repulsive force to the alpha particle. Due to that, it will return back after striking to the what? Gold foil. Therefore, Rutherford assumed that the positive charge in the atom is always concentrated in an extremely small space at the center of the atom, and this small space he called as nucleus. So the discovery of nucleus was made by Rutherford with this experiment called alpha particle scattering experiment. Okay, so what is nucleus? It is the seat of positive charge particle, okay, which is concentrated at a very small space, of extremely small space, but at the center of the atom, and that, as per observation, is called as what? Nucleus. The calculation of this, the radius of the size of the nucleus, was found to be approximately 10 to the minus 14 meter. So 10 to the minus 14 meter is the size of the radius of nucleus, which was found to be measured. That means it will lie in that range of 10 to the minus 14, even it can be less than that. And the size of the what? The size of the radius of atom, it was even found in the range of what? Order of 10 to the minus what? 10 meter. And 10 to the minus 10 meter means it also equals to 1 Armstrong. So just compare the size of the nucleus or the radius of nucleus in comparison to the size of the what? Atom. Okay, so very less. Okay, that means every atom consists of nucleus, or the nucleus size is very small compared to the size of the what? Atom. Now there are other important observation and the conclusion which was drawn by Rutherford from this experiment, okay, and that you learn in the next YouTube video.